Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of binary. That is nothing but serialize and deserialize of a binary. So before moving on to the question, if you guys are new to your YouTube channel, then please do consider subscribing our YouTube channel. So without wasting time, let's move on to the question and try to understand it. We need to perform serialize and deserialize of a binary. At first, we will focus on serialize of a binary. We try to understand what is it and how we will perform it. Okay, after that we will write it code, and at last means after that we will move on to the deserialize of a binary. We write its code, we try to understand what it is, and then we write its code. So without wasting time, let's move on to the whiteboard and try to understand it. Okay, so yeah, so here is the heading, serialize of a binary. Let me create a binary at first. So I'm creating a random binary with the data like here is 8 3 1 okay 6 4 7 10 14 and 13. Okay, this is the binary. Okay, if you don't like it, means if it is not that beautiful, so let it be. So let's try to understand what is a serializer of binary. Serializer of a binary is nothing but converting the data of a binary or the information of a binary in a string format in such a way that we can regenerate a binary from that string. Means we can like I will convert this data of a binary into some string format. Here some string format, so that when I will perform a deserialize operation, I will get this whole binary again. Okay, let's again try to understand it. Means serialize of a binary means I will perform some operation on a binary in such a way that I will convert this whole data of a binary in some string format, and whenever I want to whenever I want to share the information of that binary, I use this string. Okay, just because this string contains all the information of a binary. What the information does the binary have? It has that it has some nodes, and each node have some children. So our string will also contain all that information. Okay, if I want to share the information of that binary, I can also use this string as a substitute. Okay, and what is the other property of serialize? The other property is that I can also regenerate this tree from that string. Means I can deserialize it. So I hope you get it. We will focus on the deserialize a later on. So at first we only focus on the serialize of a binary. So this is our binary. Now what if I say that we know how to perform the pre-order traversal? Just because we have already done the quotient of the pre-order traversal of a binary in level 1, but can we perform a pre-order traversal, and from that pre-order traversal can we create a serialize of a binary? So maybe we can do this. So let's try to understand it by a by a recursive call. Okay, so we know that we can perform we perform the pre-order traversal by calling to the left hand side, then accessing the nodes and the by accessing the node, then calling to the left hand side, then calling to the right hand side. So our pre-order call will be nothing but this 8 3 1, then we get the null. Okay, let me write it side by side. Our pre-order call will be like this. At first we get this 8, then 3, then 1, then we get null. Why we are getting the null? Just because the one don't have the left and the right child. That's why we are getting the null. Again move forward, our Euler will come back, iterate back, and it reaches to this 6. Then we get this 6 as our output. Okay, now for this, at first we get this 4, we reaches to this 4, then we get null. Again, why this null? Just because it don't have the left and the right child. Okay, now we get 7, and after this 7 again we get the null. Why null? Just because it don't have the left and the right child. So our Euler will move like this. Here you can see that we have completely explored the left hand child of the this root node. Now let's try to explore the right hand child. In the right hand child, first we get to this 8, reaches to this 8, then from this 8 not the 8, oh I'm really very sorry, this is 10 actually. This 10, we get a null. Why this null? Just because it don't have the left hand child. Now the 14, then 13, and the null at last. This is nothing but a pre-order traversal of a binary tree. What if I say that I will means I will perform pre-order traversal and I will put it into a string and then will pass, and then I will use that pre-order traversal string as my serializer for binary tree. What do you will think about it? Can I use it? I will say no, I can't use this pre-order traversal as my serialize of a binary tree. Why I can't use it? Let's try to figure it out. Just because there is some flow in a pre-order traversal. The flow is nothing but, here you can see that one don't have its left and the right child. One don't have any of the child, but still here we are adding only a single null to represent that one don't have any child. We don't need to move further on for this one. Here you can see that this 10 don't have only the left hand child, means it can have the right hand child, but it don't have the left hand child. For this for the absence of this left hand child, we are only showing a single null. Means we are here also we are showing a single null. That means here we are saying that don't move to the left hand side just because it don't have the left child, move to the right hand side. So if I pass the string to the another person and I will say that deserialize it to get this similar tree, will he she be able to extract out the same tree? I will say no, just because at this point of time when it reaches to this one, he will get confused that whether this one don't will not have a single child, it don't have the double child, or any other of the case, or he will also get confused that whether this null that we have written here is for the left hand child or the right hand child. So what we will do to handle this case, this is the only flow in the pre-order traversal which we can easily handle. Okay, how we will handle, let's try to understand. Here also we just do nothing. Let me I will also create a new binary tree. Okay, so the tree was nothing but 8 3 1 6 4 7 10 14 and 13. That was our tree. Okay, so we know what was the problem with the pre-order traversal. Now we figure out sorry now we try to resolve that problem while performing the pre-order traversal. How we'll resolve that problem? We will just do a simple task. The moment we come to know that node don't have the left child, we add a null to our string just to represent that yeah, this particular node don't have the left child. The moment we come to know that particular node don't have the right child, we just add a single null to represent that particular node don't have the right child. And the moment we come to know a particular node don't have any of the left and the right child, we at this time we add two null in our string to represent that it don't have any of the left and the right child. I hope you get it. Let's try to understand it via dry run. Okay, so means how our pre-order moves. At first we get this 8, then 3, then the 1, 8 3 and 1. Then here there is two null just because one don't have the left and the right child, so we get two null. Now our Euler moves to the 6, we reaches to this 6. Okay, from the 6 at first we get this 4, we reaches to this 4, and also after the 4 we get two null. Why? Just because 4 don't have any of the child. 4 don't have the left child and 4 don't have the right child. Now again our Euler move to this 6, and from the 6 it reaches to the 7. We print it out, means we add it to our string, and this 7 also don't have any of the child, so there will be two nulls. Now we reaches to the 10. We reaches to the 10. Okay, why we reaches to the 10? Just because we have explored all the parts of the left hand side. Now moving forward from this 10, as 10 don't have the left child, so add a null for it. Move to the 14, we reaches to the 14. 14 left is 13, 14 left is 13, and 14 right is nothing but null. So this is a string, and this string is nothing but serialize of a binary tree. Now I can say it is a serialize of a binary tree. Any person will be able to extract out or will be able to create a similar binary tree from the information which we provide in with this string. Means we can easily extract out the same tree using this string, and we will actually perform it during the understanding of deserialize of a binary tree. So I hope you get it. How we'll do, we will not do nothing, just create a string and within the string we perform a pre-order traversal, and during the pre-order traversal we keep on adding the data, and we keep on separating the data by a some delimiter. Okay, what it will be, we'll figure it out during the coding part. Okay, now the another question is that what type of string we will use, whether we will use the string data structure or we will use the string builder. Now what it's a question from me to you, that what type of data structure will you use, whether you will use the string or you will use string builder. I hope you get it. What will be its answer? Now my answer is I will use the string builder. Why I'm using string builder? Just because if I talk about the functionality or the working of the string data structures, then the string data structure, what it does is that whenever I want to perform addition operation or add something new to my string, what it does, it creates a new string of some bigger size and copy all of its data from the previous string to the new string and then add a new data to it. It means the moment I want to add something to my string, it always creates a new copy of that string. But if I talk about the string builder, it doesn't create a new copy, it just add that data to my previous. So that's why we will use the string builder function within our code. And I hope you get it. What is the serializer for binary tree, how we'll create the serializer for binary tree. So let's move on onto the Pepcoding portal and we will write the code of a serialize in a binary tree. So this is public static string serialize. So what we'll do at first, yeah, we will create the string builder at first. Let me create string. Okay, string builder sb equals to new string builder. We have created a new string builder. Now serialize. I will create a new function and let me pass some parameters to that. It will be nothing but root and sb. Let's create here a new function. It is nothing but public static void serialize. This serialize. Okay, so serialize, it takes some parameters, and what will be its parameter? But tree node, root, and string builder sb. Okay, now what function we are performing here in the serialize function? We are just doing nothing. We are just performing a pre-order traversal, and we know how to perform a pre-order traversal. Pre-order traversal have two calls, one to the left and one to the right. Let's make a left call. Let's make a root dot left. That is the left call, and sb. Similarly, serialize root dot right. This is the right call. Okay, serialize. Now we have made a left call and the right call, and also we need to print the data. It means while performing the pre-order, we will usually print the data, but this time during on the position of printing the data, we need to add the data to our string builder. So sb dot string builder, yeah, this time we append some data to our here. It will be nothing but root dot val plus space between the values. Okay, now let's handle the base case. What will be your base case? Okay, the base case is nothing but encountering the null. Okay, so how we'll encounter the null? The moment we encounter how we'll handle the null, actually to handle the null, what we'll do, we need to add some delimiter to our string. So what will those delimiters? Let's figure it out. So if root equals to null, what we'll do, we just need to append okay, yeah, sb dot append minus 1001. Okay, I'm adding it as a delimiter, and I'll just do nothing but return back from the function. So I hope you get it what I have written here. I have not written anything new here. I just make a pre-order call. Okay, I hope you get it. What is the serialize of a binary tree and how we'll perform a serialize of a binary tree. Now let's try to understand how we perform the deserialize of a binary tree. So for that, let's move on to the Pepcoding. Yeah, let's move on to the whiteboard here. So really very sorry. So let me remove this data at first. Okay, we will again create it. Now our tree was nothing but 8, 3, 1, 6, 7, 6, 4, 7, and 10, 14, 13. And what was its serialize? Yeah, one more thing is that we are performing deserialize. So let me add here deserialize. So now we are doing deserialize of binary. Okay, so this is our binary, and what was it? Serialize. At serialize was nothing. At first we get this. Okay, let me write in some other color, that is 8. 8, 3, 1. These are the comma separated, or not actually the delimiter separated values. So 8, 3, 1. Okay, 8, 8, 3, 1. Here I get the null. So I'll just do nothing. I'll just add my delimiter, that is minus 1, 0, 0, 1. I think that was my delimiter. Okay, again I get the null, minus 1, 0, 0, 1. Let's move forward. We reaches to the 6. The 6 4s. Minus 1, 0, 0, 1. Minus 1, 0, 0, 1. 4. And then we reaches to the 7. Minus 1, 0, 0, 1. 7 left. Minus 1, 0, 0, 1. Actually, what this minus 1, 0, 0, 1 is showing, this minus 1, 0, 0, 1 is showing nothing but but the position of null. So that means, just for the sake of convenience, I can also replace this minus 1, 0, 0, 1 with the null, just because it will be very easy for us to understand. Otherwise you will get confused at why we have writing here minus 1, 0, 0, 1. Okay, it's here also to null. Okay, so 8, 3, 1, 2 null, just because 1 don't have any of the left and the right child. Now we reach to the 6, 7, 2 null, 7, 2 null. Now 10 null, 4, 13 null, null, and one more null, just because 13 don't have any of the child and 14 don't have the right child. This is a deserializer for binary tree. Okay, now you might be thinking that how we will extract out the binary tree, the same binary which we are getting here from this string. How we will get it? You might be thinking that. So what if I'll say that I'll do nothing? My approach will be simple. Okay, I just forgot to update here also. Okay, here also. So what if I'll say that my approach will be nothing but what I'll do this. I know that this is a string, deserialize, that the this serialize is a string. What I'll do, I will break the string into the string array. So why I'll do this, I'll just do this so that I can easily extract out this 8, 3, 1 null positions easily. Okay, so what I'll do, I'll convert it into a string, and while iterating this string, while iterating this thing, my approach will be that the moment I'm getting the data from the string, or sorry, from this array, the moment I'm getting the data from the array, if that data is not null, okay, if that data is not null, keep on adding or keep on creating a new nodes onto the left hand side, and the moment I get a data as null, that means it don't have the left child. Okay, just add the data, just add that, just update its left hand child, and start and make a call to the right hand side. Okay, make a single call to the right hand side. Just make my words like I'm saying that I like a pointer, I put a pointer here, and this pointer will keep on iterating over throughout my array. And while iterating over the array, what it does, it keep on checking that whether my data which I'm getting from the array is null or not. And the moment I come to know that the data is null, that means it don't have the left hand child. So what you'll do, you need to add that node, add that null to the left hand child, and make a single call to the right hand child. And after making a call to the right hand child, just repeat this phase again to the remaining data. So what we'll do, let's try to understand this phase on this tree. Okay, and after that what we'll do, we will create our own tree using a recursive method. So okay, so my faith was keep on iterating over the make a pointer which keep on iterating over the provided array, and while iterating over the provided array, means while iterating over this array, just check whether your data is null or not. Here you can see 8. Okay, 8 is not null. I'll just make a note and put it here. Now our pointer reaches to this 3. So I reaches to this 3. I make a left call. Okay, and as this is not null, I create a new node. Again, my pointer get updated and reaches to the 1. Here I come to know that my data is not null. Here you can see, as it is not null, I make an again call to the left hand side, and my pointer get updated and it reaches to the null. And here you can see that it is a null. So what I told you earlier, the moment I come to know that my data is null, just update it to the left hand side of that node. Means here I update null to my left hand side of the one. Now I make a right hand call. Okay, a single right hand call I make to the one's right, and here again I come to note my data is null. So what I'll do, I just update it to the right hand side of the one. Now one iteration is completed. Now as you can see that one left and right child, both of them have successfully explored. We know that a binary node or a binary tree have the nodes which have only two data, either the left data or either the right data, or we can say left child or right child. As we have explored both the left and the right child, means our scope of the working for one is completed. Means we need to backtrack now. From this one we reaches to this 3, and after reaching to this 3, what information we carry to this 3 is that we have successfully explored your left hand side. Means 3 now knows that my left hand side have explored successfully with the help of 1. Now that means we can I can easily make a link with this one. So after performing a backtracking, what we'll do, we just make this link or update this link. Okay, now as 3 left hand side has successfully explored out, we reaches to this right hand side of the 3. Okay, we make a call to this 6. 6 is not null. Okay, so we make a new node and we make a left hand side call, and here we reaches to this 4. Okay, now again, as 4 is not null, we make a left hand side call at first. The moment we make a left hand side call, we encounter a null. The null says that add me to your left hand side, and we add it. Now again we make, as left hand side of the 4 is completely explored, we move to the right hand side. Okay, we move here, and here we come to know that right hand side of the null is also right hand side of this null is also right hand side of this 4 is also null. So what we'll do here, we will make a update the link of this 4 right with the null, and we backtrack and we keep some information to this 6. What information we are carrying? We are carrying that we have successfully explored your left hand side. Means make a call to the right hand side and check and update the links there. Okay, so means we just created this link and we make a right hand side call. 6 7. 6 make a call to the 7. We explored it. We come to know that 7 is not null. Okay, so as it is not null, at first we make its left hand call, and after making a left hand call, we come to know that 7 left is null. Similarly, 7 right is null, and this 7, after updating the link with left and right, it again backtrack, and after performing a backtrack, 6 right get updated with a 7. Now as 6 left and the right child, both of them have successfully explored. Again what we'll do, we reaches to this 3. Okay, we backtrack to the 3. Now the 3, the moment we come reaches to this 3, now now 6 will carry some information to the 3. What information it will carry? It will carry that, yeah, I have explored your right hand side. Now you can trust me, you can make a link with me. Okay, now 3, what it will do, it will make a link with the 6. This link get updated, and again 3 perform a backtrack. Now why 3 are performing backtracking? Just because 3 also have 2 childs, just because it is a binary node, its left child is already explored, right child is already explored, and both of them are already updated. So we reaches to this 8, as 8 left child is already explored out. Now we make a call to the right hand side. Okay, so these are already done. the moment we make a right hand call, we encounter this 10 is not null, a new node get created, and we make, at first we make a left hand call, and the moment we make a left hand call, we come to know that 10's left is nothing but null. So we backtrack, we update the link of 10's left, we backtrack, and we make a right hand side call. This is explode, this is explode. Now we encounter this 14. Actually this is 14. Okay, so we encounter this 14. 14 is not null, we make a left hand side call. Again iterator get moved to the 13. 13 is not null, again a left hand side call is made, that is we encounter this null get updated, right hand side call will be made, and here again we encounter the null, this link get updated. We backtrack as 13's left and right are successfully explored out. So after making a backtracking call, we reaches to this 14, as 14's left is left call have already been made, so it will make a right call, and at the right call it encounter the null, that is this null. Okay, so there may be possibility you don't get that part, get the dry run. Now what I'll do, I will perform a dry run with a recursive stack. Okay, I'm going to use a stack, and there I will explain that how the stack will behave while performing the calls and how actually the links will get updated. And now we are going to make a same tree with our concept. Okay, so just wait for a minute. Okay, this was our tree, this was our answer tree which we need to make. Okay, so here we will make a tree. Let me create a stack here. Okay, yeah, we have created a stack here. So what was our approach? Let me again discuss it. Our approach was nothing but I make a pointer, we start keep on iterating over my provided array. Okay, while iterating over my provided array, what it does, it will keep on accessing the elements. During accessing the elements, if it comes to know that the accessed element means the elements which he or she, or means the elements which a particular node is dealing with is not null. Okay, if it is not null, what it does, it keep on making a recursive calls to the left hand side. Okay, means it will create a new node and make a call to the left hand side. And the moment it comes to know that the node is null, at first it updates that null with the respective left or the right child. Okay, and it backtracks, and during the backtracking it carries some information. What information it carries, that now I have successfully explored your left or either the right child, you can trust me, you can make a link with me. Okay, means during the backtracking, means after performing the backtracking, we updates the links. Okay, so let's try to dry run from the starting. Our pointer iterator will start accessing the elements from this 8. At first we get this 8. Okay, from this 8, according to our concept, we always start exploring from the left hand side. So at first we explore over the left, we reaches to the here, our iterator get updated and it reaches to this 3, we reaches to this 3. Okay, a recursive call will made over the 3. Similarly for this 3 also, we'll start exploring towards the left. Also after this 3, we reaches to this 1, and for this 1 again we will start exploring towards the left. And now we reaches to this null, and this time we encounter some, okay, I just forgot to update here, we encountered some null. Now for this null, what we'll do, at first we update the null, a link of the left, just because one's left is null. Now what I'll do, I will backtrack, again I reaches to the 1. Okay, as it reaches to the 1, this function stack get deleted out from the stack. Okay, now again we reaches to the 1. Now one's left is completely explored out, just because at the left it get encountered some null. Now it start exploring toward the one's right. Okay, now again our pointer get updated. Here also we get the null in the memory. Okay, as it gets the null, again it updates its link, that is it updates once updated its right link, and a backtrack call will be made. That means this function stack will again get deleted from the top of stack. Okay, actually this also get deleted. Why it get deleted? Just because we know that we have completely explored the one. Now we don't need to explore it anymore, so we perform backtracking. Now 1 we reaches to this 3, and after coming to this 3 we update this link with the 1. Now 3 is left, it start pointing to the 1 because it believes that yeah, 1 have completely explored its left and the right child. Now as 3's left is completely explored, let's start exploring towards the 3's right. So here it get updated with the 3 right, just because we are exploring towards the right of the third variable. Now at the right, at first we encounter this 6. Okay, so it make a call, it creates a new node that is 6. Okay, 6, and we start exploring toward the 6 left. At the 6 left, at first we get the 4. Okay, we get this 4. A recursive call will be made, and for this 4, a new function stack get created into the stack. And for this 4, we are exploring towards the left. And while exploring toward the left, we encountered the null. We encountered this null. And the moment we encountered this null, what was our fate? What was our trust to this function? The trust was just update the link with the null. So here this link get updated with the null, and it backtrack. It start backtrack. Okay. Now 4 left is completely explored. Why 4 left is completely explored? Just because we know that whenever any of the child, any of the left, either of the left or the right child encounter a null, it means from that point we can't move any further. Okay, that is the end point. Okay, so 4 left is completely explored. It make a call towards the right. So 4 make a right call, and at the right call it again encounter a null. So here again the link get updated, and now it start backtracking. The moment it start backtracking, this 4R get deleted out from the memory stack, and as it get deleted out, we reaches to this 6. At the top of our stack is nothing but 6. So we now this 6, what it does, it make a call, it update its link with the 4. It updated 6 left with the 4. Why it is updating the link? Just because it trusts the 4, just because 4 has, it believes that 4 has completed its work. It is already updated. So now we are no more exploring toward the left, we are exploring toward the right, 6 right. Okay, so at the right, at first we encounter the 7, a call will be made toward the node of the 7. Now at the top of stack there will be 7 left. Why 7 left? Just because at any moment of time, whenever we encounter any of the node, we start exploring from the left of it. So we are exploring 7's left. At first we get the null. The moment we get the null, we know how to deal with it. Again, 7's right is also nothing but null. Okay, we again know how to deal with it. Now as 7's left and right is already updated, we make a call, means we start backtracking, or the moment we start backtracking, its function stack get deleted out, and we reaches to the 6. Its right is also get updated with the 7. Now 6 left and right child is also explored completely. Now what we need to do? Do we need to move further out, or do we need to backtrack? Yeah, here we need to backtrack. So as we start backtracking, what happened? This top of stack get deleted out. Okay, and at the top of stack there is nothing but the 6. So we reaches to this 3, and as we were dealing with the 3's right, so we updated link with the 6. Now 3's left and the right child is also completely explored out. Do we need to move further, or do we need to backtrack? So yeah, definitely we need to backtrack. So from this 3 we reaches to this 8. Okay, so this function stack get deleted out, we reaches to this 8, and the moment we reach to the 8, we update its left link with the 3. Now 8 left is completely explored out. What we need to do now, we need to explore the right of the 8. So our next node is nothing but 10. We get this 10, we make a new node. I'm really very sorry. At first a recursive call node will be created, and a recursive call will be made towards the right. Okay, so we start exploring the 10. The first thing is make a call toward the left, and the moment we start making a call toward the left, okay, yeah, towards 10 left, we start making a call towards the left, we come to know that 10's left is nothing but null. So we backtrack from that side, and here x get added up. And now let's make a call towards the right, and at the right there is 4. So let's start exploring 4's left. Okay, I'm really very sorry. Here also I have updated the link. This link will be updated only during the backtracking time. So we are updating the 4, we are exploring the 4's left is nothing but 13. We get this node 13. Okay, and 13 left and right is nothing but null. We know how to deal or tackle with a null. To tackle with the null, we just need to do nothing. Just update the null to its respective cell and perform a backtrack. And during a backtrack, the moment we performed a backtrack, we come to know that we update its link with the respective node. Okay, 4 will update its link with the 13. Now 4 left is completely explored. So at the memory, there will be 4 right. Okay, no 4 left, 4 right get updated. So now we are exploring towards the right of this. Okay, yeah, the right of this 4, and at the 4, the right of the 4 there is nothing but null. So let's backtrack. Let's delete the top of stack, that is 4R. We reaches to this 10. The moment we reach to this 10, we update its right link with the 4, and again we backtrack. This get deleted. We reaches to this 8, and the moment we reaches to the 8, we update its node with the 10. And okay, so here you can see, I hope you get it, what is our concept for dealing with this for dealing with the deserializer for binary tree. And here you can see our concept is working 110% fine. Why? Just because we are getting the same tree which we use during of creating a serialize of a binary tree. So let's move on to the Pepcoding port or the NADOS portal, and there we will write the code there, and this will be our final step of this video. So this is the serialize function. Here is the deserialize function. Okay, so at first let me create a function. So public static tree node okay, let me copy the same name, deserialize underscore. Okay, so it takes some parameter that is nothing but integer type of array. And how we get this integer type of array, I will explain it soon, and even there is no need of explanation, you will get it soon. Okay, the moment I will write the code, you will get it. So just wait for some time. If index is less than actually greater than equals to, if array if index is greater than equals to array.length or array index, actually array index equals to, okay, minus 1001. So what I'll do in that case, I'll just update the index value with 1, and okay, and return null. Okay, so we are using the index, but as we are using it, we need to make it. So let me create it as static int index, index equals to 0. Now if index is greater than equals to array.length, array index equals to minus 1001. Now what we are doing, we were just getting an element and we were making the left hand side call. So let me make a left hand side call. Left hand side call will be nothing but array idx plus plus. Now after making a left hand side call, we were making the right hand side call. So deserialize array idx plus plus. Okay, so we have made the left hand side call and the right hand side call. Now the moment we get any of the node, what we'll do, we just create a new node with some function with some value data. Tree node equals to new tree node. Okay, tree node equals to tree node array index plus plus. Actually array was like this, array index plus plus. Okay, and the moment we backtrack, we need to update its nodes. So let me update the link, node.left equals to deserialize. Okay, similarly node.right equals to deserialize. Now at last we need to return something just because the return type of function is node, so we will just return the current node which is already created. That is the return node. Now let's write a call into the deserialize function, and let's call this function from the let's from this function call the above deserialize function. So what we'll do, at first we need to convert the string into the integer or string array. So string array goes to str dot split string split. Okay, and from where we need to split it, from the comma. Okay, now let's map the values that string values to the integer value. So for that, let me create a new integer. For int array goes to new. Okay, new int array dot length ar dot lenghth array dot length, and for string string as ar, what I'll do, I will update the links, or sorry, I will map the values to integer dot %, see, dot %s. So we have converted our values integer dot %. Similarly, at last, let me call this function return deserialize, this function with some parameters. What will your parameters? Parameter will be nothing but AR function. Okay, so we have successfully written our code. Let's try to run it, and if we encounter any of the error, we will try to solve it. Okay, so let's try to run it. Yeah, we get some error. Okay, yeah, it is actually it is a blunder mistake which we have made here. Like we need to pass the array only, we don't need to pass the elements. Like here we are accessing a particular element of the array, and that element will be useless. Okay, like we have already created a node of that element, so we need to pass the array. So let's again try to run it. So yeah, it gets successfully submitted. Let's try to submit it for all the test cases. Yeah, it get passed out. I hope you get the concept of serialize and deserialize. If you like this video, don't forget to hit the like button, subscribe to our YouTube channel, and please share this video with your friends to watch such more and don't forget to watch such content of the educational content on the Pepcoding website. So that's all for this video. See you in the next video.